for this session. I think it's going to be hopefully fairly simple. Hello. I'll wait a little bit for that set it up. Actually, yeah, I'll wait a little bit. Should I wait a little bit? You already started? Okay, well, yeah. So I'm just going to try to keep it fairly simple. Continuous integration. First off, has anybody used continuous integration? Yeah. No. I've only ever used it for making developing packages and for building websites, like automating the construction of websites. But there's a lot of things that you can do with it. So essentially, continuous integration generally is just the process of taking bits of code. Like let's say you're working on a team, in a team on like this code base in like a software development company. And there's like this main code base, and developers take pieces of that code base, work on it, and then merge back to that code base several times a day, so that there's less likely to be like breaks, because everybody's taking pieces from that code. And so if one developer takes a bit of that code and then makes a change that another developer is working on, and then they merge it back, there could be some type of conflict or the software breaks. And in like a commercial setting, broken software costs the company money. So constantly merging the code back into the main code base sort of allows the code to continue without having any breaks or conflicts or interruptions in services. Now, in the context of Git and GitHub, continuous integration is just essentially taking the GitHub, running the code that you tell it to run on a separate clean environment. So in this case, a server. And then what that does is it just allows you to know that your code works on a clean environment. So sometimes, just as an example, like I was developing some code to use for my data set, and I didn't realize that it really only worked on my computer because I had certain things configured specifically for that I didn't specify within the code. So then I tried to run it on the continuous integration server, and it didn't work. So I was like, well, what's going on? So then I realized the problem was that I was making the code dependent on my system. And then if you're working with teams, you can't do that because everybody's using their own system, right? Everybody's using their own laptop or whatever. And in this case, there's a service called Travis. So Travis CI or Travis Continuous Integration that works with GitHub, and it takes your GitHub repository, runs it on a clean server, and then tells you the results from that. So the benefit of that is that you find out problems with your code early on, and this can save you a lot of time later on, especially if you're working with people. It's also useful if you're just by yourself and you want to make sure that you in the future will still have your code be working as you had developed it, as you had intended it to be developed, rather than going back and then realizing it doesn't work anymore because things on your system changed. It's happened to me a couple of times. It's kind of irritating. Okay, so the main things that we need for this, or if you have any questions, like jump in at any time.
Just a quick question, like what computer programming are you programming?
So yeah, that's a good question. Continuous integration works with a huge number of programs. So the two that I'll be covering is R and Python. Who uses R or Python? I know that. Who uses
R.
R.
Comes to the very basics.
So R or Python? Python?
Really more basic.
Planning on Python in the future.
Okay. Well, and right now, what do you use?
Mostly like MATLAB data.
MATLAB. Okay. I don't think it supports those. I think the reason being is that MATLAB and Stata are commercial software. Yeah. So because Travis relies on open source software to download everything into a clean environment, I mean, it can't, it wouldn't really work. Okay, so yeah, so the nice thing about continuous integration is that it can do quite a range of things. And today I'm only going to be talking about, well, today I'm going to be doing some very simple examples in both R and Python, on GitHub. And then I'm going to show you some more complicated examples of how I've used it. Now, in the second case, you don't have to follow along, but in the first case, you can follow along. So who has GitHub? I know most of you have GitHub. Okay, so everybody has an account on GitHub and everything? Do you have an account on GitHub?
I think yes.
Okay. Do you want to like try to get that? Okay. So I'm going to try to do everything on GitHub. Now, who's gone ahead and made an account on Travis? No? Okay. So I don't think it's too hard. If you go to, I guess the first thing is log into your GitHub. So go on to GitHub. And then the second step is to go to Travis. It's travis-ci.org, I believe. Yes. travis-ci.org. So like GitHub, Travis is also a commercial company. If you keep your stuff in public, just like GitHub, it's free to use. And so this .org ending is the free version of Travis. They have a .com version that is for commercial or private repositories. So if you have a private repository and you want to run Travis on it, you need to go for the commercial version of Travis. So if you go into travis.ci.org, I think I would have to sign out. I guess I can sign out and see. So it's pretty easy, like you just sign in with GitHub. So sign in. And then it should take you automatically to the Travis CI website. Most people shouldn't see anything there if you haven't used it before. But we're gonna get that going soon enough. So first thing, if you go to your GitHub, I want you to create a new repository. So in the corner where it says the plus, just do new repository. And then I'm just going to call it testing CI R. In this case, I'm going to use R, and then I'll do Python afterwards. You don't have to do anything else, just that. Create. If you click which? Oh, here. Ah, that's kind of interesting. The first thing I want you to create is, it's going to be called Travis. So .travis.yaml or YML. So in order for Travis to use your GitHub, you need to have this file. It only looks for this file and it uses only that. So if you just create that, and then I'm just going to talk a little bit about what usually is contained within a Travis file, and then I'll go over what to actually include. So some of the main things, some of the main options that you need to include are within the Travis file are called language. So that's which particular language you're using. Install. So that's what to tell Travis to install before running things that you're telling it to do. So for example, if your code depends on some other code, you need to tell it how to install that other code before running whatever you want to run. The next thing is script. So that's the actual, that's where Travis does all of the actual work. Is it runs whatever you tell it to run. So like, let's say, does anybody know what unit testing is? Okay, some people. I'm not going to go into unit testing too much. I think we had a session on that a while ago. Essentially, it's just making sure that what your code does, what you expect your code to do is what it actually does. So this is where Travis really comes in. Is you can tell Travis to run the unit tests that then check to make sure your code does what it does in a clean environment, and then it'll give you the results of that. So if it fails the unit tests, Travis will then tell you that it's failed. The next one is you can also tell it to use different operating systems. So this is quite useful if you want other people to use your code too. So again, as an example, my code that I had developed worked only on Linux, and then I realized there was a problem that I wasn't doing correctly that didn't allow it to work on, for example, Mac users. So you can say, if you want it to run on 2 different environments, you can do Linux and OS X. I don't think it does Windows. I think that's a separate step, but I'm not 100% sure. Never tried. I think because of the way Windows has, does anybody actually know? No. Okay. Okay, so for this first example, I'm going to use R. So put language R. Because I'm going to install some packages, I'm going to do cache packages so that when it does install the packages, it keeps it on the server so that it speeds later builds of yours. Rather than having to install the package every single time, it keeps it there and then updates them if necessary. In this case, our packages. These are the packages that you want to install. So I'm going to use just one right now. It's called dplyr. And then script.
How does it deal with versions?
You can specify the versions.
So this here, it just takes the new stuff.
Yes, yeah. You can. So this is specific with R. I don't know how many people will actually need this, but if you don't include this R packages line, if you have a file in your repository called description, this is like standard within R packages. There's a file that's called description, and then it lists all of the packages that your code relies on, with the versions right beside it. So then Travis knows how to use that file. And I think there's a separate system for Python. Yeah, which I'll get to.
Question.
Yeah.
How do you add comments to that?
So that's a good question. If you do want to add comments, you do a hashtag. So this is a comment.
Can you do them
You can do it anywhere, yeah.
online as well?
Yeah, so you can do it here. So this is store packages to speed up build time. And then so on. So right now I don't have anything. So I'm just going to leave. Well, I know I want to create this one file called test. So I'm going to call R script test.r. I want Travis to run this particular file. Oh, there's also this other one. Other packages that I want to use too called test that for doing some very simple unit tests. Okay, so now you just go down and you do create. So you just commit the new file at the bottom. So you should now have one new file. Does everybody have that so far?
Oh, sorry, I missed some of the. Can I just take a peek at your file?
Oh, sure. Yeah, I'll go back into the file here. Okay. So go back to here and I'll go back to the code and then click create new file. So we're going to create a new file called function or functions.r. Again, within this, so this is an R file, so it uses R commands. Comment is a hashtag, so if you want to comment. I'm going to create two functions, very simple. Very simple and kind of silly examples, but I mean, they are trying to illustrate the point. I can make that bigger.
Is the double colon?
So I was just going to get to that. Yeah. So the double colon just says, I want to take this function called sample_n from the dplyr package. So that's all it's doing. It's just directly specifying this is the package that I want to use for this function. Now in our package development, it's pretty important to do this because there are some functions that are named the same across packages. So this just is very clear about it. Python automatically has that with the, it's like, for example, plot dots, whatever the function is. So I think you need to have that in, is that right, in Python? You need to have the dot? You shouldn't do that yet. Just to be clear, yeah. Yeah. Okay, so now just go back down, oops, and create the file. So now we have two files. I'm going to create another one. So create new file. And this one I'm going to call test.r. In here, there's a package called test_that in R that does unit testing. And again, I'm not going to get into unit testing, but all this does is just checks to make sure that your code does what you want it to do. So we're going to source, and I'll explain this stuff after I've typed it. So just to talk about this, so source is taking that that file that we had created earlier, functions.r, and importing all of the functions that I created in that file. Expect equal is where you test. So remember I had the add numbers. So 2 plus 2 should be 4. So we're expecting this to be equal to 4. The random half splits just takes a data set and then splits it in half. Randomly takes rows exactly in half. And I'm taking it from the iris, built-in iris data set in R. This I know has 150 rows, so that's why I say the actual size of this data set should be 75. So if I were to test this, they both should be 75, so it should be okay. Okay, so we're gonna commit this. So we have all of the basic workings for Travis to run its stuff. So now that we have these three files, I want you to go to Travis and then I think it's in accounts. Yeah, so if you go to accounts at the top and then go down to, should be there. Oh, it's in order. Was it in order? Wait, what is it? Sync. Syncing from GitHub. I wonder if it's my internet. I'm still good there. Okay, I'm gonna just try to refresh. Okay, that should be there now. Yeah. So down there where it says testing_CI_R, if you click it over, it's going to start doing its stuff. So if we click that, now I think you can force build. Okay, I think I actually have to. So just to get it to force it to run, you have to create a new file. So I'm going to create a new file just called readme.mb. Testing out Travis in R. So once you have that, go down and then click commit new file, and it should start running. There we go. So now it's starting to run. It should take a little bit. It shouldn't take too long because it's fairly small. But because it's the first time, I think it might take a little bit. So in the meantime, I'm going to get started with the next rather than doing with R, doing it with Python. So go to new repository. Is everything good?
So if you just want to create a new repository for the Python, create new repository. I'm going to check on this. So it said that it failed. So did everybody else have it run? Did everybody else fail? Your hasn't finished yet? Okay. Did it work? Oh, it failed. So I think I have to actually supply my own install and script steps because there's no description file. So this is where I was saying how it usually finds. Did I actually? Sorry, I'm a little scattered here. Did I include our packages? Yes, I did. Okay. Well, you can see what happens. When it fails, it tells you that it's failed, and then you can actually see what's going on. So in this case, it tells you there's no description file, so you have to add that description file. I'll show you what the actual description file looks like in my own stuff, but I'm going to do the Python stuff for now, just to speed things along. So, oops. No, that's not what I wanted to do. Okay. So we have to create another Travis file, travis.yaml or .travis.yaml. And we're going to add language, Python. Let's do OS, Linux, OS X, and then script, PyTest. So once you have that, commit the new file, create a new file. Did everybody else catch that? Is the Python? Then create another file called function.py. I'm going to keep it very, very simple. So nums, num1, num2. That's num2. Term added. I think that's all I need, right? I'm not a Python user, so I don't. Let me know it's good. Again, commit the file. Okay, so before creating the test one, I want to go and make sure that Travis will actually run on it. So if you go back to Travis and go to accounts, sync account again. Go to the bottom, switch it over, and then go back and create that test function. So in this case, we need to call it test function.py. And we do import function. So that is taking a file called function, and then do def test add nums added equals function dot add nums to cert added is equal to 4. I think that's all you need. I don't use Python personally, so I'm not 100% sure how exactly this works, but in Python, there's the PyTest that I added. So that's their format for unit testing in Python. And so I guess you need to have functions that are called test underscore, and then the file has to be called like test underscore, whatever you want to be testing. And so in this case, I'm testing add nums, and then what the unit test does is it makes sure that, again, the function that we created, add nums, 2 plus 2 should be 4. So we're asserting that 4 is equal to 4. So that should be true. Okay, and then we go down and we commit new file. So it should start running in Travis. Yeah, it's got started. And see it runs on both Linux and OS X. I don't know how long it'll take.
Is there a way of seeing the output?
Yeah. So you can actually see what it's doing in the process. So right now it's installing a bunch of stuff. Oops. And again, testing the versions, installing, running PyTest. PyTest command not found. What, did I not put in the script? Let me check. So maybe do I have to install Python?
Yeah.
So, okay, so it should be Python. Would that make PyTest? Get? You don't need quotes? Should work? Let's see. So we can see that it fails. So that's the kind of nice thing about this is you can like then start to diagnose what's going on. And like these are simple things right now. That's easy, like PyTest isn't installed. And that's fairly easy to fix. But once you start developing more bigger unit tests and more complex code, it gives you what went wrong, and then you can go back in and then fix that. And because it's like a clean environment, you know what's going on exactly. So I don't know if it's going to start building again. It started. Yeah.
So the other thing is that PyTest isn't actually included with Python.
It's not. Okay.
It is.
Yeah, it has a good topic, but like if you have Python,
So I wonder if I have to. Oh, there it worked. There we go. And look at that. You can see that automatically the command PyTest passed. So I want to go back to here and go back to the Python and go to the test function and then purposely make it so that I know it's wrong. So in this case, like let's say, or no, let's keep this here because we know that that should be the case. So cancel. Go to let's say you accidentally, like somebody accidentally introduced some code that did something that shouldn't be as you expect. And I mean, this just kind of tells you the value of unit testing is to make sure that what you're expecting the function to do does it what it actually does. I can say from my own experience, I once created some functions to clean some data up, and then at first I never created unit tests, and then when I did make a unit test, I realized that the function that I created wasn't doing what I want it to do. So then I had to go back and then fix it, but it goes to show you that it's good to have some unit tests inside. So this we know will be wrong because 2 plus 2 plus 1 will be 5, so it should fail automatically. So if we go back to Travis, go to current, it started again, and it should only be a couple minutes or seconds. You can, if you want, have Travis run on multiple versions of Python, not just 3.6 or whatever.
Can you set cache the environment?
I believe you can. I don't know how to do that in Python. I mean, in R, you just do cache packages. In this one, I don't know. But I've written up like some documentation on the website, so just an overview of this lesson, and it has a lot of links that go to some helpful resources, so you could check there.
So is the main reason behind why you do this just if it's more collaborative? Because if you were doing this yourself and you want to do unit tests, you can just run the unit tests.
Yeah, yeah.
So it's mostly just so that if other people are doing it, you're not forcing them upon them.
Yes, exactly. That's really the main reason why you use Travis or continuous integrations for other people. I would also say that it's useful even in the context of like scientific results is if you want to make sure that your stuff is as you say it is in any sort of environment. So like not just your computer, maybe there's something specific about your computer that gives it a certain result. And so you want to make sure that it's correct in not just your computer. So here, we knew that 5 does not equal 4, so it fails, and then it tells us exactly what's going on. This is the problem. And then you can go back to your code and then fix it. So I'm going to show just some examples of my own. So I created a package to deal with some things, in this case, to make it easier to make tables. So this is in R specifically. So it won't be really applicable to anybody in Python, but just to, again, sort of illustrate the usefulness of Travis. So in this case, I'll show you the description file too. So this is the description file that comes along with, that goes with any R packages. So it just gives you some like details about what version this package is, what's the name, what's the license, and then importantly, this part, imports and suggests. So these are all the packages that this package relies on. So what Travis will do is it'll check this and install this stuff in that new environment. And then with Travis here, it'll run all of these things. It'll run the unit tests that I had set up, and then build the package in that separate environment, because R has its own like process for building packages. And so you have to run those before you can actually submit to CRAN, which is like the official R package repository. And so it's fairly simple, right? Just like 4 lines of, well, I mean, 5 lines of code. And this is for our packages. It gets even more complicated if you want to do something like, let's see. This one. Okay, so this is a little bit more complicated example of what you can do. So in this case, I've set up just a series of files that will be generated into a website. So you can actually see the website at code@manuscripts.org. See if it actually gets in. So all of this has been generated from our markdown files. So because I wanted to include like code snippets, so to be able to run code inside of a document and then include that output in the website, rather than include both our markdown file and the HTML file, what I did was, where is it? What I did was I created like this script that generates the website. So there's a command called rmarkdown render site. So that creates the website. And then I changed into this, the newly created site. And then inside that, I create a new Git repository, change the configurations to Travis, add this is the domain name, and then actually commit. And then I push this newly created website to the GitHub repository. Because so the repository is at master, but now the new one is at GitHub Pages. Because GitHub Pages is the repository that can actually create the website. I know this is a little bit more advanced, and it took me a while to act, but once you get it set up, it's very easy to create. It's very easy to like then make changes to the code and then just get Travis to do all the work for you, rather than you having to do it every single time. So like in this case, see, it gets a little bit more complicated because now you have to have special Travis keywords or commands. So in this case, you're telling which GitHub repository Travis to push to. So Travis will go to the server, run all the commands, and then it'll create the new branch GitHub, the GH pages, and then push to your repository for you, rather than you do that. But you need you need to allow Travis to do that. So you can't have anybody just push to your repository. So that's why you have to have like this huge thing here, which is like a public key. I don't know. It gets a little complicated, but this is just a small example of what you could do with Travis. I see you have it like that.
Yeah, so that's that deploy key. Is it publicly?
Yeah, because this is online.
How would you figure out a way to make it not public?
Because I think it's like it's actually a public key that uses a private key. I don't know. There's documentation that tells how to do this, and like other people do this. So.
Okay.
It's not just me that's hey, this is my password. Oh shit, no, don't look. I'm pretty sure. Because I just followed the documentation on the Travis website for doing this. So if they're if they're wrong. But if anybody knows of, there's an R package called Bookdown. And it allows you to create books. There's also one called Blogdown. And if you go to any books or blogs created by these packages, they usually have things like this included. So if this is,
Yeah.
If this is the actual password, then a lot of people are putting their passwords out there. But I'll actually look into that. Yeah, I'll look into that though. If I'm wrong, then I'm gonna have to take this down. Change my passwords. Anyway, does anybody have any questions then? I mean, this second part probably was a little more complicated, but I hope like you got the gist of continuous integration.
I'm curious about the business model. So this is all free.
Yeah.
How do they provide this and when do you pay for things?
So, what's that?
Oh, is that right at the beginning?
Yeah. So there's. That's what you get for being like. No. There's two versions. There's the travis.org and then travis.com. So if you have a public repository, you can use travis.org and it's free. But if you have a private repository, then you have to pay it. Yeah. I guess that's how they make their money. It's kind of the same model as GitHub does their stuff. I would love to be able to show an example of like how you do this in Python, like to develop packages in Python, but I don't use Python, so I can't help that there. What? Oh, you have? Yeah? Okay, let's go to okay.
Just click on sponsor.
Oh, true. Good call. Travis. Cool. Okay, that's.
Dash code for the process, it'll like show you how much.
Oh, like the code coverage?
Covered.
Nice.
So don't get that cookie down here.
So this is what it looks like for developing a Python package. Again, like you can make it as complicated or as less complicated as you want. You can't really see it at the bottom there, but I guess after success is it's sending it to code coverage. So you can have a little badge there. There's, oh. Okay. The nice thing about having that up, oh, you don't have it here. Okay. I'll show you mine then. So the nice thing about having, you can put up in your README this little thing that says build passing, and so this will tell you whether Travis failed or works. So it's either failed or it's either passing. And then if you do have code coverage, you can also include another little code coverage that tells you percentage-wise how much of your code is tested. So it's a nice, like, quick way of seeing how good quality your somebody's code is if they have these types of things. So you should put yours.
Show the raw for that.
Yeah. So it's a little long.
You just like look that up, right? You just Google it and that's like.
Yeah, I mean, in R, there's a package called DevTools that if you just type out use Travis, it automatically puts that in there, which is kind of nice. Well, I mean, it doesn't automatically do it. It automatically outputs this, so you can copy and paste it into your file. Otherwise, you can, as Manny said, you can go to Google and you could probably even just copy and paste this and just change like L.W. Johnson and Carpenter to whatever, and then same thing. Very easy.
You might just have some mistake. On some repos, I've seen build success as opposed to build passive. Differences.
I don't think there's any difference, no.
They're both great.
Yeah, I think there's different. So here, this CVG, yeah, CVG. I think there's different badges that you can use, but they all do the same thing. And I think it's just depending on what you tell it to. I think it's this one. What is this? Yeah, I think it's this one. So you can actually Google Travis badges or. Anyway, there's a bunch of badges that you can use. You don't have to just rely on fail or passing. It could be success or success. It worked. Good job. Okay, I think that's it though. Anybody other questions? No? Cool.